Hello, this is Jack Jackson. In this video, we're going to talk a little bit about chi-square distributions. Actually, we're going to have two of these. We're going to have a chi-square distribution properties video, and then the following one will be calculations of probabilities and inverse probabilities with chi-square distributions. So this one is again about chi-squared distribution properties. We're going to look at some of the properties of the graph of the PDF and CDF. So chi-square are distributions here, and by the way, it's a Greek letter chi square. Chi looks a little bit like an X, so it's chi-square like that. It's spelled C-H-I, but pronounced chi. So these chi-square distributions are a family of distributions which have the following characteristics for the PDFs, at least if the what we call degrees of freedom is greater than 2. Okay, it's defined only for positive values for the input, or it's 0 otherwise if you want to call it that. So it's going to, well, at least for degrees of freedom greater than 2, it's going to start at the origin, increase up to maximum at the mode, of course, and then decrease down with a horizontal asymptote of y equals 0 on the right side. It's skewed to the right, and there's one parameter called the degrees of freedom. And the degrees of freedom is a natural number, 1, 2, 3, 4, 5, etc. And there's one distribution for each degree of freedom value. So each time you put in a degree of freedom, you get a different chi-square distribution. And let's see what else we have here. So here's an example. We want to graph a chi-square distribution with 6 degrees of freedom. Now, it turns out that on your calculator you have a chi-square PDF. So you find that same place that you find all of your other ones. Like here it is on a TI-84. You go to distributions, go down here, and actually number 7 is the chi-square PDF, so I can put that in. If I want to graph it as a function, I want to put an x value of x, put in my degrees of freedom, 5, that's what I want, and hit paste. That will get it in there, and I can graph it. Actually, a decent window, I know x's start at 0, and if I'll go out about twice the degrees of freedom, that works pretty well, or maybe a little bit beyond that. So about 10 should work. And this one doesn't get very high, so I think this is a reasonable window. Here we get, well, it's not quite leveling out there, so I need to go out a little bit. It should be leveling out to 0, so I need to go out a little bit further. Let's try a little bit more. Let's try about 20. And then we can see what the graph looks like. Yeah, you should see it leveling out on the x-axis there, right above it, of course, leveling out with an asymptote of the x-axis. Okay, so there's the graph. So why don't you try it now? Graph with your calculator 3 different chi-squares at the same time. One with the 5 degrees freedom, one with 10 degrees of freedom, and one with 20 degrees of freedom, and see how they compare. Go ahead and get them and then come back when you're ready. Press pause now. Well, here they are. Chi-square PDF of x with 5, 10, and 20 degrees of freedom, and we get these 3 graphs. Not a real good window for the last one, but it's pretty good for the first one there. Here's the same graph from a TI Inspire, and which gets a lot prettier looking graph, a little higher resolution, color, and they're labeled a little bit better. So you can see that the one here, this red one, is got both a smaller mean and standard deviation than the other two. And then that's with the lower degrees of freedom. A little higher degrees of freedom, 10, it's a little spread out, and the center is kind of shifted to the right a little bit more. The pink one, where the degrees of freedom is 20, shifted to the right even more and more spread out. So bigger mean and standard deviation the bigger you let the degrees of freedom. Now, in fact, we can actually use our calculator to get an idea what the mean is. It comes out to be a pretty nice formula here. So remember, here's the TI Inspire version, or it would look pretty much like this on the newer operating system on the 84. To find the mean in general for a distribution, you integrate over all the x's that matter, 0 to infinity here, the x times the chi-square PDF, or just x times the PDF in general, all the x's that matter, and that will give you the output. So here, if I have 5 degrees of freedom and it's a chi-square, notice that this turns out to be, well, 5 basically. And this one turns out to be 10 when I put in 10 degrees of freedom. And you could try several others, but this suggests that perhaps the mean of a chi-square distribution is the same as its degrees of freedom, and in fact that's actually true. And we could do the same thing in the older operating system over here on a TI-84. Again, this is approximately 5. That one is 10. So that's we can see the same thing there. What about its standard deviation or variance? Well, to find the variance, I'm just going to do it on a TI Inspire here. In general, to find the variance, you take x minus the mean, square it, then you multiply it by the PDF. Now, if this is a PDF with 5 degrees of freedom, chi-square, I put the 5 here, then it's x minus 5 here because we just found that the mean and the degrees of freedom are the same. And of course, you want to sum that up for all possible x values. That's going to be our integral there. And it turns out to be 10. And then when I change this to 10, this is 20. You could try several more to verify this, but it turns out that, as this might suggest, that the variance is just twice the degrees of freedom. So if the degrees of freedom is d, then the standard deviation is the square root of 2d. So some interesting things on the graph shape. Now this one here summarizes several things here. This particular one I'm graphing degrees of freedom are 10, and you can see on the same graph here there's a lot going on here, but the blue is the curve that starts at the origin, it's actually concave up for a while, increasing, then inflection point somewhere concave down, maxes out right there. That's the mode. Then it comes back down, concave down, then concave up, decreasing, and has an asymptote there. So that's the PDF. Okay. And the corresponding CDF is here, the red. Of course, it starts at the origin, and it's going to increase concave up for a while here. Somewhere in here, there's an inflection point. Actually, the inflection point happens right above the maximum here, right there at that point. And then it goes concave down, but increasing, leveling off to an asymptote of y equals 1 there. So there's our CDF in red and our PDF in blue. And it's kind of interesting. You got some really nice, couple of nice formulas. The mean is the degrees of freedom, which is where this blue line is, light blue line. So that x value right there is the mean, which is the same as the degrees of freedom, which is 10. And notice that the probability to the left is the y value on the CDF, which is given by this y coordinate 0.55951. So notice that is definitely to the right of the median. That always happens when the distribution is skewed right. You're going to have the mean to be greater than the median. And the median, of course, is where the y value up here on the CDF is 0.5. Then I've graphed the horizontal line at 0.5, and the y value is 0.5. So the area to the left of this black vertical line under the blue curve is 0.5. And so that's that x value there of 9.3418 is the median. And then it turns out that the mode, which is where the graph of the PDF is the highest, and like I said, that's also where the CDF has an inflection point, that turns out to be just 2 minus, the degrees of freedom minus 2. So notice here, degrees of freedom are 10, the mode happens at 8. So that's pretty cool. And then you capture the mean on the right, the median's in the middle, and then the mode is on the left. So its mode is less than median, which is less than the mean. This is a typical thing for, well, median less than mean at least is typical when we have a skewed right distribution. And we have that. So here's some basic formulas there. Let's take a look at this a little bit dynamically with a TI Inspire. I have this set up where I can drag this. Now, if you notice, actually, when degrees of freedom are 1, things look a little differently. The PDF actually shooting up here, shooting up the y-axis there. So things are a little bit different there. And that's also true for degrees of freedom are 2. So this graph looks a little different there. But once you get up to degrees of freedom are 3 or more, then you kind of got that same kind of shape where it's coming up and then back down. And then we can see that. So notice that as we move to the right here, we see that the graph is the center of the graph, whether you're measuring that by mean, median, or mode, is moving to the right. Notice the mean here and the mode here, these x's here and here, are always just 2 apart. This is always just, the mean is always right here on this line. This second one, I don't know if I can click on it. Yeah, there, the blue one, that one. That's the mean. This one over here is the mode. The mean's always at degrees of freedom. The mode's always at degrees of freedom minus 2. And the median is somewhere between those two, a little closer to the mean than it is to the mode. And we get an interesting view of this as we move this in and across. So we notice that with the smaller degrees of freedom, there's more consistency, a smaller standard deviation, and also a smaller mean. As we move this to the right, the center is moving to the right, and the standard deviation is also getting larger. So you see this getting more and more, flatter and spread out more for the PDF, which corresponds to this CDF being a little more, not as close to being vertical. In other words, sort of a lower slope. So we have a little steeper here, means on the CDF means that we have a lower standard deviation, and sort of a little more spread out here means that you got more spread out here as well. On the PDF and the CDF, both are kind of more spread out, and that is a higher standard deviation. So that gives you some dynamic looks at what happens as we have several different CDF and PDFs graphed for chi-squares. In the next video, we're going to come back and do some calculations using the shortcuts that we have in our calculator.